Okay, so this is the Mark II prototype of Chitty Bang. Covering's not on it yet, so it's still got big open spaces on the vertical profile. But you can see here that we've got a much bigger wing on the Mark II than we had on the Mark I. This is the template for the wing from the original prototype, or the first prototype. And I've added at least an inch of wingspan, probably a little more, and about an inch to the chord, which will hopefully give me more square inches of lift. Lower my wing loading a bit, although in the end this one was probably a little heavier than the one that I had before, because I've got a vector mounted thrust, and I've got bigger horizontal stabilizer back here. A couple other things that are different, but I'm going to plug in the battery. Okay, so we're going to turn on the transmitter and hook up the battery. You see the battery's mounted way up high on the fuselage. Got the battery here. Initially I had it down here, the theory being that if the center of gravity is low, it would be less likely to flop over and roll during flight from the weight of the battery. I may still end up putting the battery down here. The reason the battery's here right now is because I found out by testing it, by hanging it from here and having a plumb bob across it, that when the battery is high, the center of the mass is higher, and the thrust line can be around here, pointed straight at this front canard, versus having the thrust line have to be way down towards the battery. The more important than it being the canard, it's going to fly like that if I have the battery down low, whereas it'll fly like that with the battery where it is right now, which I think is better. I don't want such a high angle of attack that it's going to end up stalling as it flies. So we're going to try the battery up there. Probably going to make it unstable and roll. But you'll see it's on right now, and here are the elevators. I say elevators because I've got both the canard moving and I've got the rear elevator. So this should really give it a lot of pitch authority. Ailerons work. Get a better look at those. Pretty big ailerons. Ailerons on a cambered wing are sometimes a problem, I know. So unfortunately I don't have differential, but the mounting here should essentially give me a little bit of differential. So my understanding is that by having the aileron servo set up this way, that I actually do get some differential. We want them coming up more than they go down, and that does appear to be the case. Not ready to fly it yet. Hopefully give it a test out in the gym, indoor flying this weekend. But we've got some little training wheels down here that help it to at least roll along the ground. And there's the battery mounted high. There's some weight on the front to get the CG right, unfortunately. But the back end is so big and so far back that I need that little bit of weight. This is my vector thrust mounted motor, rather than having a rudder, because I really don't have a good place to put a rudder that's in the airstream of the prop. So elevators, ailerons, and vector thrust motor mount functioning as a rudder. And it makes that ridiculous sound with that prop. Got a 7-inch prop that doesn't make that sound, which I'll probably end up using because it gives me more thrust, and I'm going to need all the thrust I can get with this baby. Got the servo set so that it barely moves because it really gives it a lot of motion, a lot of you'll see here. So it yaws. I have ground handling control. I was actually doing better when I wasn't trying to film it, because now I'm trying to do two things at once. It's never a good situation for any pilot. Use the term loosely. But here we go. Try to move it slowly across the floor. And it'll turn one way, it'll turn the other way, and it'll turn back. Of course, it's far away now, but hopefully you get the idea. Okay. So what I'm trying to show you here is that when I apply the vectored thrust, it pushes down on the wing, and the wing opposite of where you would expect it to drop is dropping, because when the vectored thrust is pushing this way, it pushes that wing down. Even though the plane would be turning like this, normally you'd expect that wing to come up in a turn. I can probably compensate for that a little bit with the ailerons, although I don't know if I'm doing myself any favors. Well, I can steer it pretty well while it's taxiing along the ground, so if nothing else, the vectored thrust will be useful for ground handling. I may just shut it off entirely and bank and yank